and then about latent heat of vaporization. So these are the simplest one which can be asked particularly. So here questions may be asked related to the numericals. Okay, there are some numericals on these particular topics that can be also covered within that particular range. Okay, moving toward the idle past. Next is the spontaneous ignition temperature. See, spontaneous ignition temperature, as itself name suggests, spontaneous, which occurs within very short period of the time of this one, without any external or with any external firing agency. See, spontaneous ignition temperature or petroleum fraction is that temperature at which that fraction is able to catch the fire and burn continuously with the help of external agency. Okay, external firing agency. It may be a flame. Okay, it may be anything. So that is called as the spontaneous ignition temperature. I repeat again, the temperature at which the petroleum products or crude oil will catch the fire and it will burn continuously with the help of firing agency. It may be a flame, it may be particularly any other type of external agency which can be available for that durations. Now, paraffins. Now, paraffins have generally less ignition temperature, correct? Paraffins have less ignition temperature because the API gravity is very less for the paraffins. Okay, so these things are again going to be important matter in that one. So most useful for performance of the diesel fuels. Okay, so if you want to characterize the performance of the diesel fuel, then these are mostly important in that particular characterization. Okay, so performance of the diesel engine. If anyone is going to work over the characterization of diesel combined with some other kind of the additives, okay, then spontaneous ignition temperature you need to report in that case. Okay, so spontaneous ignition temperature can be reported for that particular case, and here the temperature is going to decrease with increase in the molecular weight as well as with the oxygen content of the molecule, with the oxygen content of that particular molecule. So this is what we call as the spontaneous ignition temperature for that. Okay, so these are the properties that you need to take into considerations when you are going to characterize a particular fuel. I repeat that properties again. One first is the specific heat. Okay, amount of heat required to raise the temperature of a particular fraction. Okay, for its mass. Okay, only sensible heat will be transferred in this case. So that's why Q will be calculated using mCp delta T. This should you remember. And remember that the specific heat are generally lies between 0.3 to 0.85 for the hydrocarbons which range from C14 to C70. Okay, so specific heat is calculated using generally with this formula. Next is the heat of combustion. Already where that amount of heat is released when it is burned with oxygen with its specific volume, with its known value. Okay, so hydrogen has most of the heat of combustion, which is different from other heats. Next is the latent heat of vaporization. It may be a fusion and thermal expansion for that. Okay, last property what we call as a spontaneous ignition temperature. Okay, the temperature at which the petroleum fraction can catch the fire and it will burn continuously with the help of any external agency. External agency may be the flame, it may be any type of other agencies which motivates, or you can say which forces to catch the fire at higher level. Okay, so that is called as a spontaneous ignition temperature. Okay, most important property is viscosity. Okay, viscosity is that property, especially this is specific applicable for lube oils. So everyone knows that viscosity is the property by which it offers resistance to the flow of this. So viscosity is that property of the oil which offers resistance to the flow through the device. Okay, so this property removes all the frictional forces between the two moving bodies, and based on that, viscosity index is the most important consideration, because viscosity index indicates what are the variation in the characteristics of properties of viscosity with respect to temperature. Everyone aware that viscosity goes on decreasing with increase in a temperature for any kind of this. Okay, so that already, so different devices like Ostwald DVL model is there that measure the viscosity. Then reduced viscometer is there. Reduced viscometer is specifically used for petroleum products for measuring the viscosity of that oil, and generally we are calculating kinematic viscosity. So kinematic viscosity, I think you are aware that it is the ratio of absolute viscosity to the density. And always remember, in the refinery, absolute viscosity is not considered. We are always considering kinematic viscosity, which is considered in terms of CST, that is centistokes, is the commonly used unit for specifying the viscosity of this one. It will said in literature, it will be said it is a viscosity, but if you look from unit point of view, it will be mentioned in terms of the CST, that is centistokes. So it is obviously it is a kinematic viscosity. So you need to identify it. If you take it as absolute viscosity, 100%, your answer will be wrong. If you want to calculate absolute viscosity, multiply that kinematic viscosity by its density, you will get the absolute viscosity. But in refineries, okay, the specifications are done always, even in Paris Chemical Handbook, even some Nelson book related to various petroleum products. Okay, viscosity is defined with the help of CST in centistokes as a kinematic viscosity, not as a particularly absolute viscosity. Okay, so here this is the viscosity index. Okay, so the variation with respect to temperature is done with respect to viscosity index. Always remember, if viscosity is less for a particular lube oil, means viscosity index should be high. Okay, so viscosity index is calculated using this formula L minus U divided by L minus H. Just I will point out it here. Okay, VI is equal to L minus U divided by L minus H into 100, where L is the reference oil of 0 VI at 37.8 degrees Celsius. H is the reference oil of 100 VI at 37 degrees Celsius. And U is the viscosity for the sample for which you are going to calculate its viscosity index. Clear? Okay, so this is about reference. So L and H belongs to, especially for reference oil. Generally, reference oil is considered as a lube oil also in many cases. So this was regarding the viscosity, another property. Okay. Okay. So if you have any doubt, you can put it in the comment box. I can answer later. Okay, whenever it is going to be required. So after that, the attendance consideration is there. You should like that particular, and you need to subscribe this particular channel, which is there. Okay, that will be considered as a particularly attendance of this. Now next is the crude oil transportation. Okay, moving toward the last part of this unit, that is what we call as the crude oil transportation. See, carrying out crude oil is a very difficult task. Okay, because all are particularly hazardous in nature. Okay, they are flammable in nature. So crude oil is generally transported from a wellhead to the refining section using barges or tankers. Okay, majority movements are done with help of ship movements are done. Sometimes they may be transported through the pipeline. So say the refineries are in Maharashtra are near Mumbai, okay, and another refinery is related to Mangalore. Okay, so all have the coastal region. So it will be transported through the ships, or it may be transported through the pipes if it is applicable. But pipeline systems are specifically for nearby locations, not for the longer locations. And even some kinds trucks or railroads are also applicable. Some kinds of trucks or railroads are also applicable for that. Okay, so this transportation can be done through that particular device. Okay, and these transportations are very easy under costlier. So costlier one is the road transportations. Just wait. Costlier one is the road transportation, because again for that you have to use the sources like petrol or diesel for transporting through the various kinds of the trucks. LNG is always transported through the pipelines. So if you might have seen in our city also right now, LPG connection, government is giving some complimentary offers so that people will take natural gas, LNG gas, or this particular that can be utilized in the households. Okay, so this is a one kind of force which is, but they cannot make mandatory to all. So this is regarding the transportation. So the natural gas is transported either by means of the pipelines, either by means through even through using some barges also. Even in US, these are transported through the various kind of the barges. Okay, now the first option which is available, that is oil tankers. Okay, oil tankers is the first choice for transporting the liquid. But when hazardous material bulk go through the cargoes or cargo residues, there are various types of the tankers like oil tanker, parcel tanker. Especially parcel tankers are used for chemical vessels. Means these are simple like a storage vessels, but they have been lined with certain kind of the materials. Okay, or they may be some combination of the carrier designed to carry oil or solid cargoes into the bulk phases, or some case barges may be used. Another one is LNG tankers. These are the very high pressure explosive. Okay, so that's why they are been coated with certain material which will not form the flame. Okay, so that's why they have been protected by either three different layers. Okay, or you can say that these are protected to prevent out certain kinds of the loss. Okay, so due to some scientific advancement here, the natural gas can be converted with a liquid at very low temperature, or and it may be transported as LNG, what we call as a liquefied natural gas, LNG, and the LPG gas, another one, that is liquefied petroleum gas, that may be also another way. So these are the traditional ways. We can say these are the traditional, but these are also ongoing use, because there is no any such invention which will transport your oils, crude oil, petroleum at faster rate within minimum period of time. Okay, so that kind of invention is not there. It may be available, but it is very costly. Again, cost matters a lot. So whatever preferable methods within minimum cost, how maximum efficiency of transportation can be achieved, that as an engineer we need to see. The last option which comes is the pipelines. Pipelines can refer to the gathering system, what we call as a wellhead to the processing facilities. Transmission lines may be used, some distribution pipelines may be used, and these pipelines play a very critical role in the transportation process, because the oil moves through the pipelines or at least part of this particular route. So these are the various methods which are available. Another methods are the barges. Barges are primarily used for the rivers and canals. Okay, they require less infrastructure than the pipelines, but they are very costly. Okay, because it is transporting very less volume, and it is very much taking the time either for loading and unloading. This is a very difficult task related to the barging. So barging will be preferred under that particular situations. Next is the railroads and tank trucks. You might have seen in various kinds of rails are also, especially these are called as, particularly I don't remember the names, but railroads were the primary means of petroleum transportation. Okay, you might have seen on any kind of junction or any kind of this. Okay, some kinds of even petroleum fractions are always carried out through the rails. Rails is the best option. Okay, in India, higher as compared to the US. Almost 30% of the needs are provided through the rail transports for that. Okay, so these are the various kinds of that particular transportation. So general, you can say that oil tankers, then LNG tankers, pipelines, barges, okay, tank trucks, railroad, okay, tugboats of this one. Okay, so these are the various transportation techniques. Okay, so that is the end of unit number 1, which was related to the basics for the transportation. Basic for crude oil, its composition, then its transportation, its availability in India or throughout the world. Okay, that one. So this was theoretical portion. Now remaining is only particularly equations, numericals are remain over these properties that we will cover it is in particularly during the online lecture series. Okay, so thank you so much. If you have any doubts, you can put it into the comment box. According to that, I will answer. Hope I have you understood the particular class. Thank you.